Hello everyone! Today we are going to understand the Rutherford atomic model and the famous gold foil experiment. In 1911, Ernest Rutherford proposed a new model of the atom based on his famous alpha particle scattering experiment, the gold foil experiment. In this experiment, Rutherford directed a beam of alpha particles towards a very thin sheet of gold foil. A fluorescent screen was placed around the gold foil to detect the paths of the alpha particles after they interacted with the foil. Now, let's see what Rutherford observed. First observation, most of the alpha particles pass straight through the gold foil without any deflection. This showed that most of the space inside an atom is empty. Second observation, a small number of alpha particles were deflected through small angles. This showed that the positive charge of the atom is concentrated in a very small region. Third observation, very few alpha particles were deflected through large angles, and an extremely small number even bounced back toward the source. This was a very surprising observation. It showed that almost the entire mass and positive charge of an atom are concentrated in a very small, dense central region called the nucleus. Rutherford's atomic model. Based on these observations, Rutherford proposed that an atom has a tiny, dense, positively charged nucleus at its center. The nucleus contains almost all of the mass of the atom. Electrons are present outside the nucleus and move around it. Since the nucleus is extremely small compared with the size of the atom, most of the atom is empty space. Limitations of Rutherford's model. Although Rutherford's model was a major breakthrough, it had some important limitations. According to classical physics, an electron moving around the nucleus should continuously lose energy. As it loses energy, the electron should spiral towards the nucleus and eventually collapse into it. Therefore, Rutherford's model could not explain the stability of atoms. The model also could not explain the line spectrum of hydrogen. Conclusion. So, Rutherford's experiment gave us one of the most important ideas in atomic structure. An atom is mostly empty space with a tiny, dense, positively charged nucleus at its center. Later, in 1913, Niels Bohr improved Rutherford's model by introducing definite energy levels for electrons. And that is how Rutherford's experiment became an important foundation for our modern understanding of the atom.